Hello, good morning, everybody. So, I'm here to explain about the project. My group consists of three members, which is me, Animesh, Ayush, and Devans. So, my topic was SVM inference. I had to parallelize SVM inference. So, let's see some basics of what is SVM. So SVM is basically a way to classify some input data. Like you can see in the image, uh, there are two types of data. One squares and one the other one are circles. They are are classified in different class, and they are classified using this hyperplane, which SVM uses. So there like I won't go into the intricate details of how we generate the hyperplane and all, but basically the idea is that the hyperplane divides the two classes. So if an input point is on this side of the hyperplane, we'll say that it is in square class, and if it is on this side of the hyperplane, we'll say it is in circle class. And my topic was SVM inference. So basically, we are given the direction, like given the normal of the hyperplane. So hyperplane is already given, and there are many input points, and I just need to classify them into classes. So let's see how the sequential thing will look like. So the sequential thing, let's say the input vector is x and the weight vector is w. Weight vector is basically the slope of the hyperplane. Like the normal to the hyperplane has some direction, so that is represented as matrix w. Sorry, vector w. And then we'll calculate w into x and w dot x, and if the dot product is greater than 0, it belongs to class 1, and if it is less than 0, it belongs to class 2. So this is what SVM inference is. So basically we need to parallelize this thing, just these things. So what's the sequential code? So the sequential code is just uh, this weight matrix will be basically the sorry I'm sorry. This is basically x dot w. Yeah. So weight matrix will be n cross 1 dimensioned matrix which has all the directions. I'll show you the code. See, so uh, this is the matrix which is the input matrix. Input matrix is two-dimensional matrix in which the number of rows represent the number of inputs, nv, number of vectors, short form of number of vectors. So number of inputs are represented by nv, and each vector has n dimensions. So I have made a 2D matrix which stores all the input. Basically the rows, I hope it's clear. Basically the rows are nv and n columns are there. Each input is of n dimension. So this is my input matrix. Input is stored in matrix form, and then this is, I have taken a weight matrix. Basically this is n cross 1 matrix. This represents the direction of the normal to the hyperplane. And now will the sequential code is this thing. This thing is the sequential code. we are going to each input, and then for each input we are going from 0 to n, and we are doing the cross product with weight, sorry, doing the dot product with weight, basically I matrix ij into weight of j. And if the answer is greater than 0, I say it is in class 1, and if it is less than 0, I say it is in class minus 1, like two different classes. And now we'll see the time. This is the sequential code. I'll run it. So elapsed time, I have printed out the time over here. See, I have time 1 and I have time 2, and I have subtracted those, and I have found the elapsed time. I have printed the elapsed time over here. So the elapsed time, as you can see, it's coming around this 0.014 seconds. And currently I have taken number of inputs as 2 lakhs, and each input has 5 dimensions. So let's see what if I use the OpenMP to parallelize it. So these two lines will parallelize this. Basically what I am parallelizing, there are many inputs, so each input can be dotted with the weight vector individually. So this for loop, basically all the inputs, this for loop is being parallelized. So I have written pragma omp for. So this for loop is to be parallelized, so that will reduce my time taken for this task. So let's see what's the time now. So this one is the time now. I'll run it a few more times. Let's see if it's stable or not. Okay. So this thing is being parallelized, and we have calculated the time over here. This thing. So this was my project in OpenMP to parallelize the SVM inference. Uh, this is the input I have taken. Okay, so that's it. Thank you.